before we get into some more practical real-life stuff, I want to talk to you more about slope here. Number 2, consider a line whose slope is 5/2 or 5/2. So there's my numerical value, and the point 4, 7 is on the line. So what I did here is labeled and set up an axis, a horizontal and a vertical here, and labeled. Find at least 2 other points on the line. So let P represent the output variable, so I'm going to write P here, and T the input. So there's my T axis and there's my P axis, and 4, 7 is right there. So knowing that my slope does this, I can get another point. Now what does this mean? Well, how can I get another point knowing my slope? That's the numerical value. Well, here's one way to think about slope. Another way, numerically, the slope of a line is calculated by dividing the change in output divided by the change in input, and tells us how the output variable changes, meaning increases, decreases, or remains the same for each additional input value. So when we're given a slope in terms of a fraction like this, this would mean the change in output over the change in input. In other words, the output variable P changes by a 5 every time the input variable changes by a 2, both being positive here. So what would that mean for us? So remember, this is the input, that's the output, so this is a T and a P value. Knowing this alone, this 5/2, I could come over here off to the side and do this. This is the input and the associated output. What we're saying here that this fraction does is, as the output variable increases, positive, increases by 5 as the input increases by 2. In other words, this P value, or this output value here, would increase by 5 as the input increases by 2. And that would get me to another point. So in other words, bump that guy up by 5 every time that guy goes up by 2 would give me another point. So that would mean plus 2 here would give me a 6, plus 5 would give me a 12. So 6, 12 is another point on this line. So 6, 12 is right there. Could we get another point? Well, again, the slope saying every time my output, or I should say it this way, my output increases by 5 each time my input increases by 2. So as my input increases by 2, my output will increase by 5. And that will give me another point on the line. So add 2 there to my input value and add 5 there. So 8, 17. So 8, that would be 14. So somewhere up in here off my grid would be another point. Let me label this here, 6, 12. Alright, so that's all strictly from knowing what my slope value is. So this gave me a stemming from my 5/2. Now, is there another value, another fraction that has the same value as 5/2 but not using 5/2? So this requires some thought, and there is one. There's this one. -5 / -2 has the same numerical value as this, and so if we think of this as the slope, we would say this, that my output decreases by 5 every time my input decreases by 2. So if I start with the original point, I could go the other way. In other words, this guy decreased by 5 as this guy decreases by 2 would give me another point on my line. So subtract 2 from the first, subtract 5 from the second, and that would give me at 2, 2. So 2, 2 is right here. Notice those guys are in a straight line. So we can use slope to our advantage to find points given our initial point and the slope value.